Hello everyone, Teacher Jonas here, and today we're going to review the topics regarding forces. So we're going to review forces together. First, we learned about action at a distance forces. It means that we learn about actions, which is something happening at a distance. It means without touching. So, for example, push and pull forces require contact, so they are not action at a distance. But apples falling from a tree is an action at a distance, right? Because the tree is not touching the apple to fall down, and the earth is not pulling the apple down, right? So it is an action at a distance force. Now, what force is it? I hope you remember. It is gravitational force. Gravitational. Gravitational force. Gravitational force is very cool. Whatever you drop falls towards the earth. Because gravitational force is the force of attraction. Attraction means pulling everything towards yourself. Attracting. Now, Earth has a very strong gravitational force. That's why we are all on Earth, and whatever we drop, whoop, goes towards Earth. And also, Moon orbits the Earth because of gravitational force. Now, there is something even stronger. The Sun. The Sun's gravitational force is so strong that 8 planets orbit the Sun because of how strong it attracts. So that is gravitational force. They can do this experiment at home to see the gravitational force of Earth. Now, next one is electrostatic force. Electrostatic force. Electrostatic force. Electrostatic force. Now, when you rub a balloon on your hair and it pulls your hair, it's electrostatic force. Now, electrostatic force is very cool because, for example, when you rub a plastic cup on your hair and you bring it close to papers like this one, it will pull them up with electrostatic force. Even a lightning striking Earth, it's electrostatic force. It's very cool. Now, number 3 is magnetic force. It's the force of magnets, like this one, like this one. Now, as you remember, magnets attract the opposite poles, so south and north, north and south. But they don't always attract. They also repel. When you put north and north on south and south, when you bring it close, boom, it repels each other. And this is because of magnetic force. Now, these are the 3 forces we learned in this topic, right? We learned about gravitational force, electrostatic force, and magnetic force. Now, what type of force is this? Easy. It's gravitational force because he's falling towards Earth, right? Earth is attracting him. What type of force is this? Easy. Magnetic force. He has a big magnet, right? So it's magnetic force. What about this one? It's electrostatic force. Good job. Now let's talk about magnetic. Let's review about this topic. As I told you before, magnets can be super strong, but they don't have to be big. Even small ones can be super strong, like these two. We also have weak magnets like these toys. Now, you know already which of these are attracted to a magnet. Now, when something is attracted to magnets, it can be a metal, it can be a fabric, it can be wood, but no, it can only be metal, and not even all metals. only some metals. So remember, fabric, wood, plastic cannot be attracted to a magnet, and not all metals can be attracted to magnets. Metals or things that can get attracted to magnets are called magnetic. Magnetic. For example, this knife. This knife is made of nickel. This nickel knife is magnetic because if you bring a magnet, it will attract it. Or this coin, which is made of cobalt. It's magnetic. A steel spoon or a steel paperclip is also magnetic because it's attracted to magnet. Even an iron nail is magnetic. Now, these are some magnetic objects. A metal spoon, a metal scissor, a metal key. But we have non-magnetic things too. Plastic bottle, crayon, pencil, books. They're made of paper, right? So they're not magnetic. Now, as I told you, not all metals are magnetic. For example, iron, nickel, cobalt, steel are magnetic. But aluminum, copper, lead, and brass are not magnetic, right? So they are non-magnetic. Now, remember CINS, cobalt, iron, nickel, steel. These are the metals that are magnetic. So if you have a pen made of steel, it's going to be magnetic. Now, let's talk about the last topic we learned. Push and pull forces. Now, as you remember, we learned about action at a distance forces, which means no contact or non-contact. Like this one, he's pushing the box without touching it. He's using magic. No. Or we have contact forces. Now, in this topic, we talk about contact forces that are pull and push. A force is a push or pull acting on an object, like this object or this ball, as a result of object's interaction with another object. See, this girl is pulling this object, right? Two things. This girl is pushing this ball with this object, right? So these are examples of push and pull. Forces can make objects stop or start moving. See, the ball was stopped, but when she hit it, it flew away. So it started moving. Or this girl, see, it's not moving, but she moved it. So she made it start moving by pulling it. Now, with forces such as push and pull, we can do many things. We can, for example, change the state of motion. For example, if something is going this way, you can hit it and it's going to go this way because you pushed it. Or this is not moving, right? But then I do this. See, it moved up because I pulled it up, right? It moved because of me. Or look at here. When you have dough or slime and you push it like this or you pull it, it changes the shape. So you can make the shape different. Or you can change the size like a rubber band. You can pull it to make it longer. So these are the effects of force. Look at this girl pulling a chair, or this man pushing a car. Alright, now let's see some examples of pulling forces. For example, the rower pulls the oar. Look at here. He is pulling to move on the boat. Or the tug war teams. Look at here. The tug war teams pull the rope. Or this catapult is pulled back to shoot it. A string on the bow. See, you have to pull the string. Pulling the sledge. Like the picture that I showed you. The girl was pulling the sledge, or the bell ringer pulling the rope to make it ring, 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 ring. So these are examples of pulling forces. Now, what about pushing forces? For example, the runner's feet push off the ground. When you walk, you're pushing the ground to move forward, right? Or when you want to jump, you push and you jump. A person pushes the keys on a piano, ding, 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 like this. Or like this girl, see? The hockey stick pushes the ball, right? The golf club, like this one, it pushes the ball. The bat, see? You poof, when you hit the ball, you push it away. Or this lady pushing the pram or the cart. She's pushing it. Now, we have some examples like pressing the button on the doorbell. When you press it, see, you push, right? Or sawing wood. When you're pushing it down. Or when you're brushing your hair, you are pulling, right? So when you move something away from yourself, like this, it's called push. When you move something towards yourself, we call it pull. Okay, guys, that's it for today's review. I hope you are safe, and I will see you guys later. Until next time, Teacher Jonas out. Bye-bye, everyone. See you.